All right, so let's start going over problem 31 from the January 2017 exam. Let's get right to it. All right, it says in square GEOM, the coordinates of G are 2, -2, and so 2, -2 for G. The coordinates of O are -4, 2. Determine and state the coordinates of vertices E and M. All right, a couple things here. This is a square, which means you have to know the properties of a square to do this problem. So I want you to write these properties down here that I have for you. All right. A couple things. You know all four sides are equal, 4 right angles, the diagonals are congruent, and the diagonals are perpendicular. All right. Also, the opposite sides are parallel. I didn't write that down. Maybe I do want to write that down here, add that in. Opposite sides parallel. Parallel. Okay, now, when the points that they gave you are not consecutive points, you can tell that because they give you G and then they give you O. If you look here, G and O, they're not consecutive. They're actually diagonal to each other. So we have to take that into account when we do this. So let's go ahead and plot those points. You don't even have to use the axes, but I think it'd be much easier if we did. All right, so let's plot these points. All right, so first point is going to be 2, -2. So that's going to be right here. That is our G. And let me write that down. I'm just going to label it. So that's 2, -2. And let's see, O is -4. So 1, 2, 3, 4, 2. So this is O. That's -4, 2. Now, if you connect O and G, that's actually a diagonal. Right? That is actually a diagonal. So I'm going to go ahead and do that. Now, a couple of things. We know, I'll move these properties. Move these properties down here so we can see them. All right? Now, we know that the diagonals are congruent in a square and they are perpendicular. Now remember, if two lines are perpendicular, they are going to have negative reciprocals of each other. So let's figure out the slope of OG here. Slope of OG. That might help us out. All right, so the slope is going to be, remember, rise over run. So I'm just going to count over and down, and it's actually going to be negative because of the fact that it's going down from the left to the right. So I'm just going to count down and over. So this is 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So our slope of OG is -4 over 6. All right. So that means the slope of the other 2 points, because that's what we're trying to do, find the other 2 points. The slope of EM has to be the negative reciprocal. So the slope of EM is equal to 6 over 4. All right? So that's something to help us out. Now, I mean, they don't even ask you to show much work on this problem, so you really could just guess and check. I mean, there's you could kind of put your points places and just kind of guess. Now, so I'm going to erase this part because that might get kind of confusing here. I'm going to get rid of that. All right, so let's just say we thought that the points were here and here, okay? If that were the case, okay, we should know that that is not the case, actually, because all the sides would not be equal, right? If we thought that this was E and this was M, well, that would mean this is not a square because all the sides are not equal. So we know those cannot be the points. So let's go ahead and let's do one other thing. Let's find the distance or the length of this. Let's find the length of OG, because that'll tell us something too. Because remember, the diagonals have to be the same length, and they have to be perpendicular. So let's find the length of OG. Maybe that can help us. All right, so we're going to use the same method we used for finding the slope. So we have 4, we have 6. It doesn't matter if it's negative when we're finding the length. We're just going to do 4 squared plus 6 squared is equal to c squared. So that's going to be 4 squared plus 6 squared is equal to c squared. Then you have 16 plus 36, so that's 52 is equal to c squared. And you take the square root, so c is equal to the square root of 52. So we know that the length of OG is the square root of 52. That means that the length of EM also has to be the square root of 52. And wherever it is, wherever we put our points, they have to give us a distance or a length of the square root of 52. So that's something good to know. All right. So, let's see. Let's see if you go, let's see, -3, -3, and let's see, 1, 3. All right, now let's look at these points. So let's say I thought this was it. So E and G, E, O, M. Now, if I do this, okay, a couple things I want to check for. Are the diagonals going to be equal? Are the diagonals going to have the negative reciprocal slopes of each other? Are all 4 sides of this thing going to be equal? Right? Those are some things I want to check. So let's check it out for these points. Okay, so if I did the length of each side here, so if I want to find the length of EO, I can just make my right triangle, and that's going to be 1 squared plus 1, 2, or 1, 2, 3, 4, 5, right? So that's going to be 1 squared plus 5 squared. And then if I did up here, it would be 1 squared plus 5 squared. If I did over here, right, for this side over here, it would be 1 squared plus 1, 2, 3, 4, 5, and same thing here. So that tells me all of my sides that I have in blue are all going to be the same length. So that's a good thing. Now, are my diagonals the negative reciprocal of each other? So I'm going to do the diagonal here from E to M, and I'm going to take away some of this stuff. A lot of this could just be guessing and checking, As long as you know the properties of a square, you can do some good guessing and checking to get your answer here. But if I want to find the slope here, remember, you're going to do rise over run, right? So it's going to be 1, 2, 3, 4, 5, 6, and then 1, 2, 3, and 4. So that means the slope is right for the diagonal. That means these are our points. E is going to be -3, 3, and M is going to be 1, 3. All right, look at number 32. It says triangle QRS is graphed on a set of axes below. Now below it says, on the same set of axes, graph and label triangle Q prime, R prime, S prime, the image of QRS after a dilation with a scale factor of 3/2, centered at the origin. This 3/2 could also be just seen as 1.5, all right? And when you're dilating and when you're dilating a figure centered at the origin, all you have to do is multiply the original coordinates by the scale factor. So let's do our original coordinates. We have Q, R, and S. So Q starts off as negative 2, 2, and we're going to multiply that by 1.5, or 3 over 2, and that's going to give us Q prime. All right, and let's do R. Let's just write down all the points first here. So R is 2, 0, and S is 4, 6. And we're going to multiply these all by 1.5. 1.5. And let's see, we're going to have R prime, S prime. All right, so Q prime, when you do that, it's going to be negative 3, 3. R prime is going to be 3, 0. And S prime is going to be 6, 9. So I can graph those now. Negative 3, 3 is going to be right here. This will be Q prime. And then we have R prime will be here. R prime. And S prime is going to be 6, 9. Right, so right here, that's my S prime. So I'm going to just make my triangle. By the way, if you didn't see it, the notes over here. Talk about a translation really quick. It's not a rigid motion transformation in that the size and shape don't necessarily remain the same. The only time they would remain the same is if you were dilating by a scale factor of 1, okay? But typically it's not, unless it's a scale factor of 1. It's not a rigid motion transformation. The corresponding angles are congruent, and the image is similar to the pre-image. So you have two similar figures, okay? So we did the first part of this problem. Now we have to explain why Q prime R prime is parallel. That means parallel, all right? Remember, when two lines are parallel, the slopes are going to be, the same, all right? So, slope of QR is equal to, all right, so I'm just going to, in blue, I'm going to do the slope of QR. It's negative because it's going down from left to the right. So the rise is going to be negative 2, run is going to be 4. So our slope is going to be negative 2 over 4, which is also 4, negative 1 over 2. All right, now what's the slope? The slope of Q prime R prime. Now I'm coming back up here, Q prime R prime. This time I'll go over and then down. Right, I went too far, should have been here. So our slope is going to be down 1, 2, 3. So negative 3 over 1, 2, 3, 4, 5, and 6. So our slope is going to be negative 3 over 6. Or negative 1/2. So since the slopes are equal, we can say that QR is parallel to Q prime R prime. All right? Okay, looking at number 33 on the exam. It says to use a compass and straight edge to construct a regular hexagon inscribed in circle O below. Inscribed means inside. The hexagon should be inside of the circle with each one of its vertices touching the circle. A hexagon is a 6-sided figure. So let's start off with that. 6-sided figure. And when it says regular, it means all these sides are the same length. All right, so 6-sided. Here are the steps, and I want you to write down these steps. All right. So draw a circle of any size. In this case, you don't have to draw the circle because the circle is already drawn for you. But you are going to want to figure out what the radius is. So when you see step 2, it says keeping the same opening of the compass. Place the point anywhere on the circle. So really what that's saying is find the radius. These directions I have here is if you start off and had to draw the circle yourself. So here the circle is drawn. So we want to get the radius, get that opening. All right, now we're going to go anywhere on the circle. It doesn't matter where you start. You're going to put your compass point anywhere on, and you're going to make a mark. Now, you could draw the entire circle. However, you're going to have to do this 6 times, and if you remember from class, it can get kind of messy. So we can just go ahead and draw an arc or a part of the circle, and we're going to go around the circle until we get 6 marks, 6 arcs. So let's go ahead and do that. And if you have a compass, you can follow along. If not, just pay attention and make sure and write down those directions so that you are clear on what to do. All right, so I'm going to do this, go all the way around. If you remember in class when we did this, if you actually do the circles, you get a flower, which looks interesting for those of you who like the, like art. It's actually pretty nice looking. All right, so what you're going to do now is, now I said to label the points 1, 2, 3, 4, 5, and 6. Actually, here it says label it A, B, C, D, E, and F. So we're going to go ahead and do that. Make sure and put your points there, because we don't want, I know students, they get this far and they start connecting the ends of the lines and doing things that they're not supposed to do. So put the point where the circle intersects the arc, or where the arc intersects the circle. We're going to connect these points. All right, so now I'm going to have A. Okay, I'm just going to write them in. It's going to be a lot faster. So we labeled it. Now that's the first part. Now, also says leave all construction marks, so you don't want to erase your arcs that you made. Okay? Now, next thing, at the bottom, a couple things. Let me get rid of this first here. Okay, it says if chords FB and FC are drawn, which type of triangle, according to its angles, would triangle FBCB? Explain your answer. So what I want you to do is write this definition of a chord. A chord of a circle is a straight line whose line segments, whose endpoints, both lie on the circle. So we're going to draw in FB and FC. All right, so let's go ahead and do that. So FB, and I forgot, I never even made the hexagon, so let me go back and do that. I have to connect these points. So let me do that right now. All right, there's my hexagon. Now I want to connect my points FB and FC. So I'm going to go from F to B, and then F to C. All right. Let's see here. So what I'm looking at now, I'm looking at triangle. We're going to see what type of triangle FBC is. So let's focus on FBC. So F, this triangle right here, according to its angles. Now, if you notice, angle B is an inscribed angle. They're all inscribed angles actually, but what is an inscribed angle, you might ask? Well, I want you to write this down. An inscribed angle is an angle with its vertex on the circle formed by two intersecting chords. Okay, so write that down. All right, so now, I'm going to focus on angle B. That's this one. Now, if you notice, this FC is actually a diameter. This actually cuts the circle in half. And if I focus on this angle B, it actually intersects right here. And what you're left with on this side, this arc, it's half the circle. So there is a little theorem that we're going to look at. Now right here, I want you to look at this. Here we have an inscribed angle. And I want you to focus on this right here. It says the inscribed angle is 1/2 of the intercepted arc. Okay? So now on this example, we have this angle X here, which is inscribed, and the arc that it cuts is 82. And we know, based on this, based on what I just circled here, that this angle up here is half of this arc that intercepts. So that's why they say the measure of the angle is 41. Well, let's look here. Let's look at angle B. It intercepts an arc. This green arc is half the circle, so that's 180. Based on our rule we just looked at, that means this must be 90 degrees. That means the triangle FBC is actually a right triangle. All right, so we're going to write that. Triangle FBC is a right triangle. Angle B is a right angle because it is inscribed and intercepts an arc whose angle is 180. All right? So there we go. If you have any questions, just ask.